Okay, we have lesson 7.9 for Algebra 1. We're going to look at special products of binomials. So in the last lesson, we looked at multiplying polynomials together, specifically two binomials, and we looked at foiling. So we're going to use that concept a little bit today. Let's do our warm-up first. So again, please make sure you guys are doing the warm-up. Can't really reiterate that enough. It really helps you to make sure you know what you're doing. Okay, so 4 squared. When we multiply 4 by 4, we get 16. Number 2, 7 squared means 7 times 7, so that is 49. Negative 2 times negative 2 is going to be a positive 4 because a negative times a negative is a positive. X, and then all of that squared is going to be just x squared. Negative 5y squared, well, there's no exponent outside, it's just this negative sign, so we can drop off those parentheses and write it as negative 5y squared. Number 6, it's a variable with an exponent and then raised to another power, so those get multiplied together, so 2 times 2 equals m to the 4th. And we need to distribute this 2. Now, again, you only are multiplying the 2 by the constant, and the only constant is the 6, so that becomes 12xy. Okay? Again, here we need to multiply the 2 by the 8, so we get 16x squared. So we're going to look at finding special products of binomials, and you're going to hear things here, perfect square trinomial, and then the difference of two squares. So imagine that we have a square with a side length of a plus b. Okay, so we're saying that the side length of the square is a plus b. The area of the square will be a plus b times a plus b, right? Because the area of any square or rectangle is the side length times itself. Well, specifically a square, it's going to be the side length times itself. So we can say that a plus b times a plus b is the same thing as a plus b squared. The area of the square can also be found by adding all the areas of these little smaller rectangles together. So if we added all those up, that would be a squared plus ab plus ab plus b squared. And they're getting that from here's your a, here's your a. So that times itself gives you this area. Here's your little b, here's your b. So b times b gives you this. And then for this one, it's going to be the area is going to be a plus b. So a plus b squared actually is equal to a squared plus ab plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. Now that can get a little confusing, so I actually just like to look at it from being FOILed. So if we have a plus b squared, that means we're taking a plus b times a plus b. So we're going to FOIL, take the first, so a times a is a squared. The outer, they did it down here, a times b is ab. The inner, b times a, and you can write it in either order, a, b, b, a. And then the last, b times b, which is b squared. Now, these are like terms, so that becomes 2ab. So in general, a trinomial that has the form a squared plus 2ab plus b squared is called a perfect square trinomial. That means it's the result of having a binomial squared, okay? So any binomial times itself, okay? So let's try this. So x plus 3 times x plus 3. I'm going to do the x times x, so that's x squared. X times 3 is 3x. Then my inner, 3x, and my outer is 9. Now, again, we can combine these middle terms, so it's x squared plus 6x plus 9. So the shortcut for any binomial that's squared is it's the first term squared plus the two terms in the inside multiplied by each other and then doubled. So 3 times x is 3x, and then we double it to get 6, and then it's the last term squared. If that's too confusing to remember the shortcut, you can always FOIL it out and to make sure you're on the right track. So 4s plus 3t times 4s plus 3t. So the trick is we take the first term squared. So 4s times 4s is going to be 16s squared plus these two terms times each other and then doubled. So 4 S times 3t is going to be 12st. So if it's doubled, that means I have 24 of them. And then the last term is just the last term squared, so plus 9t squared. So you have to square that whole thing. If you don't like this, again, you can FOIL, okay, if you don't like the shortcut. All right, so let's do the last one. So it's the first term squared. 5 times 5 is 25. It's the two terms times themselves and then doubled. So that's 5m squared. So if I double that, 5m plus 5m becomes 10m squared. And then the last term squared. M squared times m squared becomes m to the fourth. And you're done. So let me just show you one last time. If I were to FOIL that out the long way, I would get the same answer. So I get 25 plus 5m squared plus 5m squared plus m to the fourth. And then I combine these, so I get 25 plus 10m squared plus m to the fourth. So you can get the same answer by FOILing it. Whichever way you like is fine. So you can use the FOIL method to find the product in the same form if I have a minus b squared. So instead, if I have a minus sign instead of a plus, it's the same thing. So it's the first term squared, the last term squared, and the middle two terms times themselves, but we have a minus and doubled, but a minus sign now. So it's the same idea. We just have a minus sign. So let me do it the long way first. So x times x is x squared. X times 6, it's a minus 6, so it's going to be minus 6x. Minus 6 times x is going to be another minus 6x, and then minus 6 times minus 6 is a positive 36. So make sure that last term is always a positive, even if this is a minus, because we're multiplying a minus by a minus. So we combine like terms, we have two negative 6's, so that becomes minus 12x plus 36, and you're done. Okay, let's do the shortcut on this next one. So it's going to be the first term squared, so 16m squared. Then this term times this term with a minus sign. So that's going to be 40m, but we have to double it. Okay, the middle term is doubled, so that's going to be 80m. And then plus, always plus, even if there's a minus sign here, the last term squared. So that becomes 100. Okay? I'll FOIL the next one just so we can see, and then I'll do the shortcut on the last one. So 2x minus 5y times 2x minus 5y. So first, we get 4x squared minus 10xy. We have both an x and a y. Then a minus 10xy again. And then a positive 25y squared. So we combine these, so we get 4x squared minus 20xy plus 25y squared. Okay, let's use the shortcut on the last one. So it's the first term squared, which is 49, minus the middle two terms times each other and then doubled. So 7 times r cubed is 7r cubed. And if we double that, that's 14r cubed. Sorry, that should be a little cube. And then plus, always a plus, even if there's a minus in here, the last term squared. Well, r to the third times r to the third, we add those together, so that becomes r to the sixth. Okay? You can use an area model to see that a plus b times a minus b. There's another shortcut here. We're going to see the special product binomial. So if we have one binomial that they look exactly alike, except one has a plus, one has a minus, the shortcut is that it's just the first term squared minus the second term squared. And we don't have a middle term because it drops off. And this is called the difference of two squares. That's because if you multiply it out, they're basically the middle terms are canceling. And you can kind of read through this little description here. It can be kind of helpful, but I think it's easier if I just write it out. So a plus b times a minus b. So if we do the first term, that's a squared. Second term, it's a minus ab because I've got a minus here. Middle is a plus ab. And then the last term is a minus b squared. So if you notice, a minus ab and a plus ab cancel out, and all you're left with is a squared minus b squared. That's why this is the shortcut. So again, it has to be the same binomial, just they have a difference of sign. So that's your difference of two squares. So let's try this. So again, if we see that both beginning terms are the same and the last terms are the same, and all that's different is the plus and minus, you can take the shortcut by just taking the first term squared minus the last term squared. So 4 times 4 is 16, and you're done. Okay? So again, we've got the same thing, just a different of a sign. So that means that we can do p squared. So that becomes p to the 4th. And then the last term, it's always a minus here, is aq squared. So aq squared, that means I have to do the 60. I'm going to get 64, and then I'm going to get q squared. For this last one, let me FOIL it out again to show you. So 10 times 10 is 100. 10 times negative b is negative 10b. 10 times positive b is positive 10b. And then b times negative b is negative b squared. So if you notice, negative and positive, they cancel, and we're just left with 100 minus b squared. So again, you can always FOIL if you're worried that you're messing up, but the shortcut is to just know, you know, these 3 different techniques. So we've got when we've got a polynomial a plus b squared, there's a trick. The a minus b squared, there's a trick, and then the a minus b, a plus b. So this again is, you're going to have a squared plus 2ab plus b squared. The second one's going to be a squared minus 2ab plus b squared, whatever those terms are. And for this last one, it's just the first term squared minus the last term squared. Okay, so we have one last problem to do. Write a polynomial that represents the area of the yard around the pool shown. Okay, so this is the yard around the pool. The pool's floating in here. Let me actually erase that, and I'll just color the pool blue, since pools are supposed to be blue. Okay, so that's the pool, and it wants to know what is the area around the pool. Okay, so just that area around it. So first we have to find the total area of everything around it. Well, if we look at this big square, we have a side x plus 5 and x plus 5. So to find that area, we're going to multiply those together. X plus 5 squared. So that is going to be our first term squared plus our 2 middle terms doubled, multiplied and then doubled, so 10x, and then plus 25. Okay? The area of the pool is x minus 2 times x plus 2, so x plus 2 times x minus 2. That shortcut, remember, is the first term squared. We don't have any middle terms since they have an opposite sign, and then minus the last term squared. 2 times 2 is 4. So we've got the total, we've got the pool. To find just the area around, it's going to be the total minus the pool. So how we do that is we take the total, x squared plus 10x plus 25, minus the area of the pool, x squared minus 4. Okay, so this has to get distributed, remember, so it becomes a minus x squared plus 4. I'm going to rewrite this out. Okay, now I'm going to combine like terms. My minus x squared and my positive x squared cancel. So I have 10x, 25, and a minus 4, or positive 4, sorry. That became positive 4. So I have 29 plus 10x, or 10x plus 29, whichever order you want to write it in, okay? So just note again, remember to subtract a polynomial, you're doing the opposite sign. This is a really good slide to have. This gives you the summary if I've got a plus b squared, a minus b squared, and a difference of 2 squares. Those just walk you through it. You guys can always FOIL if you don't want to memorize the little shortcuts. If on this last one I had asked like a bonus question, I had said, okay, so if that's the area around the pool, what will the area be if x equals, I don't know, let's say x equals 5. So this is the area around the pool, and I said, okay, what's that area if x equals 5? So if x equals 5, all you have to do is plug in x and get 29 plus 50, which is 79. So that's just kind of another step if I had asked you to do that. All right, and we're done.